So in this lecture, we are going to explore sliding window technique. Sliding window technique is a powerful algorithmic approach for efficient array processing. It is a very common approach to solve problems related to arrays. And this technique is actually implemented using the two pointers. So as an introduction, this sliding window is an algorithmic technique used to efficiently process array or list when maintaining a window of elements, and it provides an effective way to solve problems involving subarray, substring, or contiguous sequences. So, so before we look into the sliding window, let's try to understand the concept of subarray. What exactly the subarray is. So subarray is a contiguous sections of the array. All the elements must be adjacent to each other in the original array and in their original order. So for example, if we take an example here, let's say 1, 2, 3, 4. Okay, this is the this is a given array, so the subarray could be the length of 1 is 1, 2, 3, 4. Similarly, if we talk about the 2 length, 2, 2, 3, or 3, 4, or it could be 1, 2, 3, and 2, 3, 4. As you can see that it is the contiguous section. We divided contiguous sections into one each here. In the second, we are taking two elements at a time, and they are also contiguous. Like the 1, 2 is the contiguous, maintaining the order. Similarly, 2, 3 is maintaining the order. They are contiguous sequence. The third one is also the same thing. Here we are talking about the three elements at a time. 1, 2, 3, 2, 3, 4. Right? Both are maintaining their order and the contiguous. Also, 1, 2, 3, 4. This is also in the subarray. Okay. The subarray is always have a contiguous sequences and it maintains the order. A subarray can be defined the two indices. For example, here it's only one indices, that's left bound and outbound, both are same. So we can define the two indices, right? So left bound and the right bound. Okay, if you see here, this is the left index and this is the right index. And these two indexes are define the boundaries of the server. And this is exactly we are talking about. If we have the two indices and both left and rights define the boundaries, we can name it as a window as well. Okay, so coming back to the sliding window, which is an algorithmic technique used to efficiently process array or list by maintaining the window of the elements, right? Now, let's see the basic concept. Now, the basic concept, as we see in the array, right, we is define the two pointers, right? The left bounds and the right bounds, basically representing the boundaries of the windows. And in initialization phase, we do start from the first set of the elements within the window and then perform the operations of the element within the windows, then move the windows, right? So define the 2 pointers. You start with the first set of the elements within the windows, then process the perform the operations on the elements within the windows to based on the requirement, like how the what is the ask in the problem we have. So there are two approaches which basically we need to take, right? First, we need to identify the problems. We need to recognize them, whether they are suitable for this sliding window techniques. And we also need to determine the size of the window based on the problem requirement. So let's see how these techniques work and how do you identify the problems. So to identify the problems, whether they are suitable for the sliding window technique, or like you have to look for some attributes in the summary. Like it could be the sum, the number of unique elements, or the frequency of the specific elements, or any other attributes, right? And the second thing is there is a restriction as well on the constraint matrix. For example, they would say the summary is valid only if the sum is less than or equal to 15. The constraint matrix here is the sum of the summary, and the numeric restriction is the condition, which is saying that is less than or equal to 15. A summary is considered valid if the constraint matrix conform to the numeric restriction, that is, the sum is less than or equal to 15. The second thing is the problem will ask you to find valid summary in some way. For example, they will ask you to finding the best valid summary. It will define what make a summary better than another. For example, a problem might ask you to find the longest valid summary, or it will ask you to finding the number of valid summary. We'll take a look at this in a given example. So for example, let's say we have this is the problem statement, find the maximum sum of a summary of size k in the array, right? So maximum sum. Now you have to find, for example, you have given an array and you need to find the summary that sum is maximum, right? And it should be the size, like the subarray has the size of k. So let's see how we can do. So here we have an example. Let's say this is a given array of 6 elements and the k value we have given is 2. Okay, and we have to find the subarray with the maximum sum, right? Now we have to find the maximum sum of the subarray. So here's the k is 2. That means the window is should have 2 elements, right? So we have this is the our left index, this is the left bound, which is a 0, and this is my right bound, which is 1, and this is representing my window. Okay, the left bound and the right bound. So as per the basic concept, we define the 2 pointers that representing the boundaries of the windows here. And we have to find the maximum sum. So we're gonna start with these 2 elements. The elements of these 2 index within the window, right there, which is 3 and 2. And we're gonna find the sum of this, which is 5, right? And we see the problems doesn't tell us what will be the max, right? We have to find the maximum in this window, right? So we need a variable that will keep track of the maximum. Okay, so this will represent, this is here is my window sum. So I will say window sum I calculated based on the left bound and right bound, and I also need to define a max sum variable that will be keeping track my maximum, right? So what in the first step we have the initial window, we calculate the window sum, which is 5. Now we have to slide the window. Now the next, we are sliding it to the next element. So we remove the third here. We're gonna get rid of this one and we're gonna move it to the next one. Now my left bound index is pointing to the 2 and my right bound index is pointing to 1. Now my sum will becomes 3. This, we have to compare the maximum and the window sum. So the new window sum is 3, which is not the, which is less than the maximum, which was the previous sum, right? So my maximum is still pointing to the 5. I will slide by window again. Now we are uh, calculating the sum of this one, this two, which is 6. Now 6 is greater than my previous maximum, which was 5. So maximum is now holding the value of 6, right? Window is sliding again, and now it will see the 5 and 6 is the same, right? So maximum doesn't change. It's still 6. It doesn't matter whether we are uh, it's changing or not, right? It's the same thing. Then the window slide again to the last two elements, and that will be the 3. Maximum is still 6, so we're gonna return the 6, right? Let's see how we turn this into the code. So here is the code snippet for quick representation. So we have this method written here, which is taking the array and the k values, right? So k is the window size, right? And we have to find the maximum of the subarray, right? Now, if you can see the first, we are iterating through the array up to the k, right? That means like we're starting from the 0 and we are going to the k, which is, if we are taking in the example which we just saw in the pictorial representation is 2, and we are getting the window sum, right? Now we also define the maximum variables that is going to keep track of the window sum. Then we're going to move from the k to the next, to the end of the array one by one. And what we're going to do is we're going to add the element of the new index and we're going to remove the last elements, right? So, and that's, and the next step, we are also comparing the maximum versus the window sum. And ultimately, we are returning the maximum. So that's pretty much it with this maximum server example, right? So if we look at the applications for the sliding window technique, these are the problems statements. You will see the pattern, right? Maximum, minimum serverism, finding the substring or the subsequences, pattern matching, and anagrams, optimization problems. And in the real world example, you will see a lot of uh, help in the data streaming applications, financial data analysis, and string manipulations in natural language processing. So these are the main real-world examples where the sliding window technique is very efficiently uh, process the data. So if you are talking about the space complexity and time complexity, it takes constant space, which makes it very memory efficient. And in terms of time complexity, it's a linear time complexity like O, and so it's very efficient.